Okay, good morning. So let us continue the lesson. This is just one single theorem left from all the lesson that we need to do. And then you will get some time to start practicing on these two chapters so that we can have the test on week 21. By the way, I changed, it was wrong. I wrote 22 now, I changed it to 21. Thank you that you mentioned. It's a very simple theorem and it's a very nice theorem. So it tells you that if you have a circle, yes, you have a circle, you don't care about the radius, you don't care about where the center is located, but you have two intersecting chords, okay? These chords can either intersect inside or outside, okay? So let us consider two cases. Let me just consider the first scenario, that I have two chords, one this and the other one this. They are somehow intersecting inside. You will be in camera. Yeah, your computer is in that. Okay, great. Okay, so I have two intersecting chords, and then the length of these are somehow very nicely related. So if the length here is A, and the length here is B, the length here is C, and the length here is D, a very nice relation is telling you that A times B is always equal to C times D. Okay? So it doesn't matter how you draw these chords. As soon as they intersect, you get 4 line segments. The product of these two is always equal to the product of these two. Yes, it's a nice relation. We want to see why this is the case. Okay? So to prove this, what we do, I changed my color. So what I want to do, I'm adding some lines to this picture to be able to prove this for you. So I will actually connect this point to that point, and I also connect this point to that point to make triangles. Okay, so let me give them names, by the way. So for example, let me call this one A, let me call this one B, let me call this one C, or might be it is better to call it D here. It's close to D, and then let me call this C. It doesn't matter, of course. But then I give this one also a name, so let me call this intersection point M. So my claim is that these two triangles that you see are similar. Okay? Why they are similar? It's extremely simple. I want to convince you that two of the angles from this one are equal to two angles of this one. One angle is clear, yes? If I call this one M1, and if I call this one M2, you agree with me that M1 and M2 are equal, yes? So I would write this. So M1 is equal to M2. If you want to give the reason, you say that vertical angles. But there is another angle. So for example, can you tell me why this angle that you see here is equal to that angle? This is the topic of the previous lesson. So this is an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and the arms are chords. Yes? So D is an inscribed angle. Why this inscribed angle D is equal to this inscribed angle B? Why is that? Because that was the famous theorem that last time, yes? If I ask you, what is the arc subtended by this angle? So this is one leg, and this is another leg, so I have 2 points here and there. This arc that you see here, that I am just going through it again, this arc is the arc subtended by this, yes? And if I ask you what is the arc subtended by this one, you would say, okay, this is one leg, this is the end point, this is one leg, this is the end point. So the arc subtended by this angle is exactly the same thing. Yes? And then both of them are inscribed, and we learned this in the previous lesson, that if I have two inscribed angles, both subtending the same arc, they are equal in size. You remember that? We have totally forgotten. Yes or no? Okay. So this means that I would say that angle D is equal to angle B inscribed. This is important to write in the exam. Inscribed angles subtending the same arc. For example, AC. Okay? Okay. Now, because of angle theorem, so these two triangles are similar. So therefore, by angle theorem, triangle AMD is similar to the triangle B or CMB. It doesn't matter, of course, the order. CMB. When the triangles are similar, I can write the equality of the corresponding ratios, yes? You don't need three of them, but let us, for practicing more, I want you to write all of them for me. For example, in the numerator, I decide to write the sides of the bigger triangle. It doesn't matter, you can decide to do it with the smaller triangle. Okay, so I would write AM, I would write DM, and I would write AB. These are the only sides that we have for the bigger one. So this is up to here, it's completely arbitrary. But then when you have chosen this order, you have to respect the order in the denominator. So tell me, when I write AM from the bigger one, what should I write from the smaller one? Yes?
CM.
CM. Why is that? Either you can, in your head, twist it a little bit and put it here to understand what is going on, or you can reason like this. You would say that AM is opposite to D in the bigger one. Which angle was equal to D? It was angle B. Which one is opposite to B is CM. So this is one way also to understand it. So what about DM? If I choose DM from the bigger one, what should I choose from the smaller one? BM. Why? Because if this angle is equal to this angle is equal to this angle, automatically this angle will be equal to that angle. So when you write DM, it is opposite to A. This angle is equal to A. What is the opposite side is BM or MB. Okay? And of course, you don't need to think about the last one because the only one is left is what? BC. But it is clear for this problem, it is true, but it is useless. So you don't need to consider this at all, yes? Because this is saying something about AD and BC. But I don't want to prove something about AD and BC. I want to prove something about AM, MB, MC, and MD. So even though this is also true, but we don't need it. Yes? So we don't need to write it. I mean that in the exam you really don't need to write this one. Okay? I just wanted to do this for more practice. Okay, but this one, let me ask you, what is AM? What is AM? AM is A. What is CM? CM, you see it is C. And what is DM? It's D. what is MB? It's B. And then if I use this famous rule that A times B is equal to C times D, I have my theorem proven, yes? So it is a very simple consequence of this inscribed angle theorem. Because if I couldn't conclude that these two angles are equal, then I was not able to conclude similarity of triangles, and I couldn't write that one. This is an immediate consequence of that. But that's a very, very handy tool if you are working with circles and you want to calculate some length, of course. Is that clear? But there is also an alternative. What happens if the chords are not intersecting inside? Is there any relation we can say? There is also a relation we can say about that, but it is actually you need to extend the chords, yes? If I have two chords, let me just name them again A, B, and C, D, but this time I draw them in a way that they are not parallel, but they will not intersect inside. The extension of them will intersect outside. Okay, so for example, let's take this one, and then I have CD. Okay, let me make it capital. Okay, and then what I'm saying is that let us continue this and continue this so that the extensions will actually intersect somehow. So it's hard to draw it in that way. Let me something like this. And let me call this point now point M. Okay, so let me tell you something here. When this intersection point is inside, let's look at the way that I move the pen. So MA times MB is equal to MC times MD. Something like this, okay? So I start from the point of intersection, I go to the right and to the left of that point in each chord. But if this happens, this is not as nice as this one, but still there is a relation. So what you can write MB but times MA, okay? MB times MA is equal to MD times MC. This is what we want to show. Okay? So if the intersection happens inside, it's a very nice relation as you see in the picture itself. But if they do not intersect inside, you cannot write a nice relation between these two immediately. If you insist to write something, then you have to continue these two so that they intersect at some point outside. Then you can, we will show that. We can write MA, this length, times this length is always equal to this length times that length. And it's a very interesting property. So it means that, look at it in a different way. You have a circle and you have a point outside. And then I draw a line like this. I draw a line like this. I draw a line like this. It doesn't matter how I do it. It's very interesting that this product times that is always the same. This product times that. This product times that. They're always the same. So it doesn't matter. Where are you doing? What are you doing? Okay, so this means that MB times MA is equal to MD times MC. I will repeat this again, but let us first prove the theorem. Why do you think this should be correct? So we have to prove that. So this chord theorem has two alternatives. One alternative is actually very nice, but another alternative is like this. That's also nice, but if you look at this in this way. So why this is true, do you think? Why MB times MA is equal to MD times MC. Again, the idea should be similarity of triangles. Because these kinds of relations are indeed these kinds of relations. And these kinds of relations comes from similarities, yes? So how can I have two triangles? So do you remember in the original picture I didn't have triangles at all. I added these two dotted lines to make two triangles myself. So something like this should also happen here. So I need two triangles, yes?
You draw line like from B to D and A to C.
A to D, B to C, yes, that's correct. So this you need to write in the exam if you want to add something to the picture. You say that, okay, we join A to B and B to C.
Yeah, sure.
Okay? So you need to write it in words. But which triangles do you think? There are many triangles now involved. But which triangles are similar and useful? You need to tell me about triangles so that some of the sides are these sides, yes? MA, MB, MC, and MD should be involved somehow. Okay, can you see which triangles are similar and why? Yes, Rasmus?
Pick the triangles ADM and ABM. Or no, CBM.
CBM. Can you tell me why? So let me just mention which triangle you are talking about. He is talking about ADM, this triangle that you see here, with this triangle CBM. He is claiming that these two triangles have to be similar. Okay, why?
Yeah. Why can't we say that?
Okay, so that was a guess. Okay, so what is your answer, Rasmus? You don't know?
No, actually, I don't know.
Okay.
I can't say.
Oscar?
So, on the intersection of the cross there, it's
Yes.
obviously opposite angles.
Here,
Yes. Those two are.
these two,
No,
these two,
yes, those two.
but that's not related to the triangle that Rasmus mentioned. I don't know if you have a different idea, that's okay. But what Rasmus said, if you want to follow him, this angle is not that important for these two triangles, even though you are right, they are equal. Yes, here?
Angle A and angle C are equal because they're subtending the same arc.
So that's completely correct. You see, this angle is equal to that angle. Why? Because they are inscribed. Why they are inscribed? Because the vertices are on the circle, and the one leg is a chord, another leg is also a chord. That is an inscribed one. The same scenario for this one. So that's also an inscribed. But if I ask you what is the arc subtended by this, you will show me this arc. Do you agree? And if I ask you what is the arc subtended by this one, you again show me the same thing. So this means that they are equal, yes, but that is not enough.
And also angle M.
Angle M is completely in common, yes. Angle M serves as an angle for this triangle as well as this triangle, yes. And that is enough. These two triangles are similar. Thank you. So what we write, we say that angle A is equal to angle C. We can write inscribed angles subtending the same arc. Here we can write BD, okay? And then M is equal to M, a common angle, yes? Or they common, because that's the only one, yes? Okay, so this means that the triangle, so therefore angle-angle theorem implies that the triangle ADM is similar to the triangle yes please, triangle CBM. Okay, so this means that I can write the ratios, but this time let us write the ratios that we need rather than writing all of them and crossing one of them over. So which ratios we need? Okay, so here what I write, I want to write two equal ratios. from this triangle, I want to choose the sides somehow are involved in my equation, as in my relation that I'm going to prove. So MA is one of them. So I will take MA here and write MA. And then the other one from this triangle is what? MD. So I would write MD. These two are involved actually. Yes, this bigger triangle that you see here, there are three sides for that. One of them is MA, one of them is MD, one of them is AD. But it is just wasting time if I want to talk about AD, because AD is not involved in what I'm going to prove. So that is enough. But as soon as I wrote these two, then I don't have any choice for the denominators. I have to follow the rules. If I write MA for this upper triangle here, what should I choose for the lower one? What should I choose from here? MC. Yes. And if I choose MD from here, what should I choose from there? MB. Yes. And then it's clear. I can write MA times MB is equal to MC times MD, and that is what I wanted to show. So these are two versions of the chord theorem. So let me just tell you why that is correct. So when I chose MA from here, okay, MA is opposite to this angle. If you can, in your head, invert the picture and understand, that is better. But if you are sometimes confused, you can reason like this. So this angle from this triangle is definitely equal to this angle from the bigger one. Okay, when I have chosen MA from this one, it is opposite to this D, and then D is equal to B. Opposite to B is MC. So if I have chosen MA from the first one, I have to choose MC from the second one. And what about MD? MD from the upper triangle is opposite to A. A is equal to C. Opposite to C is MB, and that is why I have written MB. So I really don't insist to do this, but if you can imagine, it is better and faster. If you don't, you should do this. So that's a very two versions of the chord theorem. One version is that the chords intersect inside. One version is that the chords intersect, but if you just continue them, not inside. And this is also a good picture. Let me draw something for you here again. So this means that if you have any circle and you choose a random point outside, let me call it M, and then you start drawing some chords. Okay, so this is not, by the way, a chord. This line is called a secant. Secant means cuts the circle. Yes, so it cuts the circle. This part is a chord, but the whole thing is called a secant. Okay, so if I draw some secants, so for example, let me call this one x1, and this length, okay, I don't know how to call them. Let me call this one y1, and then I will tell you what happens. Or, okay, let me change my notation. Let me write this point A1. Let me call this point B1. And I draw another one. Yes? And then let me call this point A2. Let me call this point B2. I don't know, you can draw another one. You can draw infinitely many, of course, but let me just randomly draw some of them. So this means that if you continue in this way, there is a very nice relation, even though the lengths of these are all different, but something interesting happens is that if you multiply MA1 by MB1, it is always a constant. It is equal to MA2 multiplied by MB2, and it is equal to, I don't know, MA3 multiplied by MB3, and you can continue this list. Which is not trivial, yes, because by starting changing the inclination of these lines, I am really affecting these lengths. This length is not equal to this length, obviously, and this length is not equal to this length, obviously. But the nice thing is that if I decide to multiply these two lengths, and I do the same thing here, the products are the same. Yeah, is that clear? Okay, let us start. The lesson is completely finished. Let me start doing some problems we can do together, okay? And then you have plenty of time to practice, but of course there are 2 chapters involved. And I will start updating the Google Classroom as I promised, to make it more clear for you which parts you have to read, or what are the topics that you need to know. Mainly, whatever I taught in these 2 chapters are important. Logarithmic functions and actually this geometry. The only thing is that the last part of the geometry we have already covered, and we have already done the test, the analytic geometry, yes? So we don't need to do that anymore. Okay. So let us try to solve some problems. So remember, the movement of your hand when it is inside, it is in opposite directions, yes? But when it is outside, they are in the same direction, yes? I don't know, let us, for example, one of them is actually very simple, but let me just start. This is problem 5064. I am just using the hard copy version, but it doesn't matter, I will draw it. So I have a circle here, according to the picture. Everything is expressed in centimeters, and then I have this chord, which is of course extremely simple, this problem. A, B, and then you have some C, D. Yeah, forget about the scaling. I cannot respect that scaling that much here. But this is given to be 7, 3, 3. This is given to be 5, 1, and this is given to be 6, 2, and this part is wanted. Extremely simple, isn't it? Yeah. So what can I do? I can use this Chord Theorem, yes? I can just say that, okay, let me, instead of question mark, let me write it x. And then I would say that, okay, 6, 2 times x is equal to 7, 3 times 5, 1. And then I want to look for x. So x becomes 7, 3 times 5, 1 divided by 6, 2. And then everything, you can calculate it using your calculator, and then the answer would be in centimeters. But let us not spend some time on it because it's extremely simple. Okay, let us solve more interesting ones if I can see. For example, problem 5067. This picture is given. Yes, you have a right angle triangle in this form. Okay, so this is 90 degrees according to the problem, and it is mentioned to be AD and P and C and B. So the sizes are given 4, 2, everything is again in centimeters. And then you have 6, 8 here. And then you have 6, 6 here. And the question is to find the area of the triangle, the big triangle, ABP. Area of triangle ABP is 1. But I think that's also simple, isn't it? You want to find this area. Okay. I want to hear from you, okay, what to do. Yes, Sergey?
We use the second Chord Theorem to find out what BC is, and we use the Pythagoras Theorem after that.
We use Pythagoras Theorem or what?
First, we use the second Chord Theorem.
Okay, so it means that, let me call this one x and second Chord Theorem. So it means that by second Chord Theorem, what can I write? Can you tell me?
6 comma 8.
No, just write the letters first. BD, PD times what?
AD is equal to.
Not AD. Did you say AD?
Oh.
Be careful. I told you about the movement of my hand. PD times PA. PD times PA is equal to.
DC times. No. BC times PD.
Okay, so let me just move from this direction. PD times PA is equal to PC times PB, yes? That is what we write. I think I recommend you to start from the point of intersection and just move in one direction, okay? But I have seen the students get confused sometimes. They write PD times DA. Be careful, that is wrong. You have to write PD, don't be lazy. Go back and then go forward again, okay? So PD times PA. Okay, so PD, so I can find x, but I have to be careful. What can I write for PD? It's 6 comma 8 multiplied by. What can I write for PA? PA is what? 4 comma 2 plus 6 comma 8, yes? That is PA. That is PA. But what is PC? PC is 6 comma 6. But what is PB? PB is 6 comma 6 plus the x that I don't know. Yes? And then if you see there is one relation and one unknown, so in principle we should be able to solve it. Okay, I might need your help for your calculator, but this is simple. So I just become 7, 11. So I have to multiply 11 here. If I put 11 here, 6, 8, 6, 8. And it becomes 8, 4, and then 7. So this becomes 7, comma 48. So this number is 7, is 11. And if you multiply 11 by that, am I right? No, it is 1, comma, not 2. 74, comma 8. Yeah, I appreciate if you double check the answers, okay? And then you have to multiply 6 here. This number multiplied by itself. So can you help me with that? So multiply these two, please. What's the answer?
43.56.
5, 6. And then I multiply this here, but I have to write it like this. And can you also subtract these two, this minus that, this minus that one?
31 minus 24.
Is it right? Yes, that's correct. 24 added to this one is 0.8. 0.31 to this one is 7. Yes, that's correct. And this is 6 comma 6x. And then I find x. So x becomes 31.24 divided by 6 comma 6. Okay, what's the answer, please?
4.7. Or do you want decimal or?
Yes.
4.73 repeating.
4.73. Okay, so let us keep how many decimal points to. Okay, so that's good. That is centimeters. Okay, but now I want to find the area. For finding the area, I need this side and that side. Yes? But this side, I have to use Pythagoras Theorem to find. Yes? As you mentioned. So what I do, let me write it here. So I will use the Pythagoras Theorem. So I would say that PB squared is equal to AP squared plus AB squared. But what I have for PB is by the way, I know PB, so let me write PB here. So therefore, PB is equal to 6 comma 6 plus x. So this becomes 6 comma 6 plus 4 comma 7. So it becomes 11 comma 3, yes? Okay, so this I know, I can put it here. It becomes 11 comma 3 squared. What do I know about AP? Yes, AP is how much is 11? So it is 11 squared plus AB squared. So then I can calculate AB. I move this to the other side. 11 comma 3 squared minus 11 squared is AB squared. Okay, can you also calculate this and then take the square root of that? So AB is 11 comma 3 squared minus 11 squared is AB. This is my AB. What's the answer? No one is calculating. Thank you very much, by the way. Yes. Pardon? I don't know. They told me to come in here. Okay, so what was the number? So 11 comma 3 times 11 comma 3, which is this one, then minus 121. So what I get is the square root of 6 comma 69 is AB. And then you take a square root. Hopefully I have done everything right. So AB becomes equal to 2 comma 6 centimeters. Now that AB is clear, the area, what is area? It is AB times AP divided by 2, yes? This is the area. But I know that AB is 2 comma 6 multiplied by AP, which is 11, and then divided by 2, yes? So let me also continue the calculation. Multiply it by 11 and then divided by 2. Hopefully I have done everything right. This becomes 14 comma 2 centimeters squared. But of course we want to keep only 2 significant figures. Might be in the book you see the answer is just 14. Okay, let me double check that if you have done everything right. 50, 67. They have written 15. This I really don't know. They have answered that the area is 15 centimeters squared, so that's a big difference. Let us double check our calculations. Can I borrow a calculator? Yes.
Why did we wrong?
That's not a big problem, I don't think. So, of course, that's a big problem because you make an error here, you make another error here, you make another error here. So you're accumulating the errors. So I hope that, because essentially we haven't done something wrong. Might be the only calculation, the numbers are wrong, okay? So what we have done, let me double check the calculations, yes. So according to the calculator, this answer is 7.44. And then I take the square root from here. Square root of 7, 44. So this is 2 point, I don't know, is this so important, but this is 27.2. So that's 27. And then I go for the area here. PA is 11. I multiplied by 2.7 here, and I divided by 2. Yes, so that was important. The answer becomes this. So then, this is, I take it away. That was good. That was my mistake. Okay, so now it's correct. Thank you. Thank you very much. Okay, so everything I told you, the calculation is completely correct. So I missed this part. Okay, so actually that's it. The rest, I think it would be good if you start practicing on your own. Yeah. Any questions? Okay. For the time being, I think it's good to practice on these two last lessons, this Chord Theorem and this inscribed angle theorem. And then I will update the Google Classroom so that you know what you are supposed to do. So there are 2 chapters involved. So the only thing that we have studied, but it's not included in the exam, is the last section, which is analytic geometry. That is not coming in the exam. But everything else in the last 2 chapters is included in the exam. Okay, thank you.